In today's video, we will be focusing on the second stage of central dogma, translation. For tens of millions of years, one of the most fundamental events that must occur in nature is the passing down of genes by chromosomes from parent to offspring in order to ensure the continuation of a species. This is because the DNA within the chromosomes carry the instructions for synthesizing trillions of unique proteins, all of which are needed to execute the countless different biological tasks of a cell. This process of converting genes, which is known as the central dogma, which is a principle which states that genetic information flows from DNA to RNA by transcription, RNA to polypeptides via translation, and finally from polypeptides to proteins by folding. Phase 1. Initiation. In initiation, a complementary strand of RNA, known as mRNA, which is messenger RNA, has just left the nucleus and arrived in the cytosol of the cell. This is because it has just been transcribed from the original template strand of DNA in the first stage of central dogma, transcription. Now in the initiation phase, the mRNA must locate and bind to a ribosome composed of ribosomal RNA, ribosomal proteins, a small and a large subunit, as well as an A, P, and E site, which acts as the factory for protein synthesis. This is because the ribosome holds special sites that directly bind mRNA with transfer RNA, tRNA, molecules, which are clover-shaped RNA molecules that fix to an anticodon on its head, with a complementary sequence of base pairs that correspond to the codon and mRNA. The methionine tRNA will bind to the 5' of the mRNA's template strand and rapidly scan down the strand in the 3 direction until it finds the first AUG start codon. Once this happens, a larger ribosomal subunit will immediately affix itself to a smaller subunit and complete the ribosome, concluding the initiation phase. This is triggered because the anticodon in methionine tRNA is able to recognize the start codon on the mRNA due to the complementary relationship. The initiator must carry methionine specifically, that is, the amino acid, because it corresponds to the AUG start codon. The tRNA is joined by amino acid through aminosylation and creates a new aminosyl tRNA. At the end of the scanning process, the tRNA will end back up in the P site of the ribosome where it will act as a future building block for future polypeptide chains to grow off of in the next phase. Now in phase 2 of translation, the second incoming tRNA molecule with the proper anticodon and amino acid bind to the next 3 base pairs. On the mRNA in the A site of the large ribosomal subunit, this step is energized by the hydrolysis of a GTP molecule rather than ATP. Right after the methane already present in the P site is cut off from the initiator tRNA molecule and forms a peptide bond with the second amino acid delivered by the second tRNA in the A site. The formation of this peptide bond is catalyzed by ribosomal enzyme peptidyl transferase. At this point, the 2 amino acid long peptide chain has removed the old tRNA in the P site and fixed itself to a new tRNA in the A site. Now the ribosome moves down a codon, continuing down the 3' direction. The 2 RNA molecules remain fixed to their codon, so this shift leaves the A site vacant. The second tRNA with the 2 amino acids in the P site and the old tRNA in the initiator, and the initiator tRNA in the E site where it will leave the ribosome. Final phase of translation is termination, and it begins once a stop codon, so UAA, UGA, or UAG, is scanned in the A site. Once this occurs, a protein release factor, rather than amino acid tRNA, will bind to the codon and cut off the newly formed polypeptide chain from its tRNA molecule in the P site. With no amino acid to form a peptide bond within the A site, polypeptide chain is released from the ribosome and the ribosomal subunits separate from the mRNA strand, along with the release factor. With the dismantled polypeptide chain and the site of the protein synthesis, the translation state of the central dogma is concluded. However, the polypeptide is still in an inactive form and remains non-functional. That is because it has yet to be properly shaped into a protein. This will later occur in the third stage of central dogma, folding.